A lot of toxic gases are released during this procedure. Chloromethane is toxic, carcinogenic, and flammable. Welcome back everyone. Today we are going to make chloromethane. For this, 60 ml of 96% sulfuric acid, 100 ml of methanol, and 45 grams of sodium chloride are needed. We are using an excess of methanol and a large excess of hydrogen chloride to flush the apparatus in the beginning. For safety reasons, we are working in a very well ventilated area, and a lab coat and a gas mask as well as nitrile gloves will be worn. We started off by adding the sodium chloride to a pre-dried 250 ml Erlenmeyer flask. 50 ml of 96% sulfuric acid were measured out. This sulfuric acid will be used to produce hydrogen chloride. We added the sulfuric acid to an addition funnel. Together with the sodium chloride containing flask, this will be used as a hydrogen chloride gas generator. The 100 ml of methanol were transferred to a 1 liter 2-neck round bottom flask. To this we slowly added 10 ml of concentrated sulfuric acid to act as a catalyst and dehydration agent. You can see a cold trap that contains some anhydrous calcium chloride. Here you can have a look at the entire apparatus. At the right, we have our hydrogen chloride generator with a hot plate on the bottom to increase its efficiency. Hydrogen chloride will then be passed through this tube into the methanol and sulfuric acid mixture. A stirfish has been added to increase efficiency. We are going to reflux the methanol the entire time. Any produced methyl chloride will then be passed through this tube into the cold trap containing calcium chloride to dry it. Excess HCl will be led to a gas trap standing outside. We turned on the heating mantle and waited for the methanol to start boiling. And while I waited for the methanol to boil, I prepared the ice trap. For the ice trap we are going to use a mixture of crushed ice and acetone. This will get cold enough to condense the chloromethane. The dry ice was added first to the cold trap. If the acetone was added first and the dry ice afterwards, you would get a lot of splashing. The test tube was lowered down into the ice bath. This test tube contained calcium chloride. The anhydrous calcium chloride will act as a drying agent and it will suck up all of the water that mixed over. By now the methanol was refluxing nicely. This meant that we could start the hydrogen chloride generator. The reaction taking place here can be seen above. Sodium chloride reacts with sulfuric acid to form hydrogen chloride and sodium sulfate. Hydrogen chloride is a toxic gas you should definitely not inhale. I turn on this hot plate below the hydrogen chloride generator to increase the efficiency. When you look closely you can actually see a fine mist. It's likely that this is hydrogen chloride dissolved into methanol. I'll let all of this continue for quite a while. To show you that actually gas is coming over, I turned off the stirring. You can see some hydrogen chloride bubbles in the methanol. There are quite a lot of bubbles produced in the hydrogen chloride generator and I turned down the sulfuric acid flow to stop it from overflowing. At some point we took out the test tube to look what we had collected. Nothing. But as it turns out, we will get more product later on. The reaction continued and more stuff started condensing in the condenser. This looked not like methanol, it looked like a mixture of methanol with something else. When taking out the test tube a second time, we actually collected some clear liquid. The methanol reacts with the hydrogen chloride in an esterification reaction, forming methyl chloride and water. The sulfuric acid, which acts as a drying agent, shifts the equilibrium to the right side of the equation. This esterification is rather uncommon because we are actually using a gas instead of a liquid or a solid as the acid. More and more product was collected. At some point I switched off the heating mantle because it looked like water was coming over. As the heating was turned off, you could see some backsplash in this gas tube at the right side. I stopped the liquid from making it over into the hydrogen chloride generator by simply disconnecting the hose. At the end, we were left with this much liquid. I decided to temporarily store this liquid into a homemade lecture bottle. The bottle was cooled down using dry ice and the chloromethane was added using a funnel. You can see a lot of white vapors being released. This is hydrogen chloride that had dissolved in the chloromethane. In theory, this problem could be solved by bubbling the chloromethane through a sodium carbonate solution before condensing it. But because I didn't have a second washing bottle, we had to do this step separately. A slow gas flow of chloromethane was turned on. With this needle valve, it is extremely easy to control the gas flow. The washing bottle was filled with sodium carbonate solution to react with the hydrogen chloride to form sodium chloride, which will be left behind in solution. Chloromethane makes it over and we are going to condense it in those ampules. The ampules were cooled down using this dry ice block. The chloromethane makes it over, impurities are removed and even water is removed by some calcium chloride anhydrous that's contained in the syringe. If you look closely, you can see these bubbles forming in the gas washing bottle. This is carbon dioxide, which will fortunately not condense in any of our ampules. Once full, I took the dry ice block outside to seal the ampules. A good seal can be ensured with a little bit of skill and an oxyacetylene torch. The neck was heated and then stretched out using a pair of pliers. Unfortunately, one of the ampules didn't want to get sealed and I failed with it. This is the ampule with the broken seal. I turned it over and the chloromethane spilled out. We ended up with 15 grams of impure chloromethane inside of the lecture bottle and some more inside of these ampules. This represents a yield of 29.7%, which is quite low. To show you the hydrogen chloride impurities, I took the lecture bottle outside again and opened it a little bit. Pure chloromethane would not form those clouds. And there you have it. Some chloromethane in ampules, and this chloromethane is clean. And some chloromethane in this gas cylinder, which is still heavily contaminated with HCl gas. This will be okay for my next synthesis though, and if it is successful, I'm going to pin up a follow-up video on this stuff. So if you liked it, feel free to give me one of these and consider subscribing to my channel for more awesome chemistry stuff in the future. I'm wishing all of you a nice day. Until next time, bye.